Today's class is a very short one. We're just going to go through a few slides talking about the whys and stuff of the notes for it, of why there is a different thermostat for it, and what thermostat do we need for it. Oh, hold on one second. Apologize. Give me just one more second. Apologize for the difficulties this morning. All right, let's get started again. Sorry about that. So today we're going to be talking about the notes that are associated with the 15 Seer single stage silver series heat pump and air conditioner. If you've looked in your price guide, or if you've looked online at the matchups with it, it includes a note that a two-stage thermostat is required to get the AHRI rating of the unit. Now, I'm sure you're asking yourself, how does a single stage condenser require a two-stage thermostat? And that's what we're going to talk about today. So the biggest portion of this, come on, is we're going to talk about why is the thermostat needed, what kind of thermostat is needed, and the installation and wiring of that thermostat. So the why. When American Standard brought the product for efficiency testing, with a single stage stat, it couldn't achieve the higher numbers that it needed, in some cases for the tax rebate. So by actually using a two-stage thermostat to change the indoor fan speed, that's all we're changing, is we're reducing the indoor fan speed. We're reducing the wattage of the indoor blower, which on that system will now bring that efficiency up to where the higher points are, in some cases allowing it for a tax rebate. So just by changing that indoor fan speed a small portion, it will change the efficiency enough for it to qualify. Now, I'm sure you're asking yourself, right? As long as I've been in this industry, when I slow down airflow, I have the possibility of freezing coils. You have to keep in mind that the TXC coil and even the air handlers that we use are used for our variable speed product as well. So the TXV that's installed on that product will actually allow that coil to stay at a safe temperature. Now, if you have a bad refrigerant, or not a proper charge, or you have a bad duct system, that'll exacerbate the system and make it even worse, right? Because we are slowing down the airflow. So making sure that you have a proper duct system and that you have a proper charge in the system is going to be very important. Again, if you're raising your hands, please don't. I can't call on you. If you have a question, put it in the Q&A. Now, what type of thermostat do I need? For our system to hit that AHRI number, you need a thermostat that has a Y1 and Y2 call. And all that Y1 and Y2 is going to do is, on that indoor unit, change and reduce that fan speed on a Y1 call, allowing us to get lower wattage on that blower to create that AHRI number. So any two-stage thermostat will do that for you. I don't care if it's Honeywell, one of American Standards, or whatever brand you're using. As long as you have a Y1 call and a Y2 call is all that you need. Now, of course, you'll need low voltage wires going down to the unit to be able to do that, to be able to turn on the functionality of that unit. So let's get right into the 5TEM4, right? This is the same TEM4 air handler we've been using for quite a while, but this is the one that's set up for the new refrigerant. So one, it does have the mitigation board wired into it. And one of the things they also added to it was the Y1 and Y2 wires. So when you look at the wire bundle of it, you'll see that there's actually a Y1 and Y2 wire available for hookup. When you first buy the air handler, they're twisted together. Also, they added a single pole relay to change that fan speed when you have a Y2. So what will happen is, right, for one is your low voltage connection, and then you've got the relay itself. So these are a couple of pieces that are added from the original TEM4 to the new 5 TEM4 for the new refrigerant. So blowing up just those two sections, if you look at the center of the screen, you'll see that there's actually a yellow wire that is noted as Y1, and then there's a yellow wire with a red stripe. That is our Y2. And when you purchase the air handler, those two wires are twisted together so that if you're using a single stage stat, your installation does not change. But if you are going to use a two-stage cooling stat, this is where you would hook up that Y2, is that yellow with the red stripe that will allow it to change that fan speed. And how it changes that fan speed, if you look in the bottom right, I cut that out of the wiring diagram. They added a single pole relay inside the control panel, which will change that fan speed. Wiring, right? Everything still hooks the same. Your R to your R, your G to your G, your commons together. Your O goes directly out to your outdoor unit for activating your switchover valve. And then you've got a Y1 and Y2 that are going to connect from your thermostat to your air handler. Now on your air handler, you also have a YO. YO stands for your outdoor. So this is where you're wiring in your condenser. Why you don't want to hook it to just to one of your regular Y wires is your mitigation board will not activate and turn off that compressor when you have a mitigation issue or you have a refrigerant leak in that evaporator coil. So you want to make sure that you're hooking your YO to your outside so that your mitigation board will function correctly. And then your W connections will still be the same as if you're doing a single stage heat or if you're tightening your heat separately. Now, one of the things I do want to point out is that the setting up the airflow on the unit. In most cases, you're going to find that the airflow is already pre-set up for you correctly, but you're definitely going to want to confirm it. And also, you probably want to use a manometer or MagniHelix to make sure that your airflow is correct, right? We can look at a duct system and say that with a 16-inch duct, we can get this much airflow through it. But again, if we have it hung in properly or if we've got massive bends in that flex duct, our airflow can drastically drop. So my suggestion is always to do it with a MagniHelix to find out what your true airflow is of that system. So for the 5TM4, we're going to use the 06 air handler, and we're going to set it up for a 4-ton outdoor unit, which means in high speed, Y2, we want 1600 CFM, right? 400 CFM per ton. And then in low speed, we want 1120. And how I came up with the 1120 is 1600 CFM times 0.7. We're okay to a 30% reduction in airflow for that low speed. Our TXV will monitor down to that 30% reduction and allow us to work in that case. So with the air handler, I don't have as many speed taps as I do with the gas furnace. So my options are fairly limited. So in this case, if I do a traditional duct system at 0.5 inches of static, I see that over under the tap 4, I've got 1656 CFM. So that means I want tap 4 for my high speed. Now, anytime we reduce airflow, our static is going to change on that system and reduce as well, right? If I'm pushing less air through it, my external static pressure is less as well. So in this case, I'm going to use 0.4 inches of static. Closest number I have to my 1120 is at 1426. So I'm going to put my low speed or my Y1 tap on that 1426 and make sure that tap 2 is being utilized. These will all be in your installation guides, and they'll show you how to set up those CFMs by which tap you're using. And again, my recommendation is always use a MagniHelix or a manometer to make sure that your static pressure is correct and your duct work is performing the way you would expect. Now on the S8X1 furnace, wiring is fairly similar, right? I'm running a Y1 and a Y2 from my indoor thermostat to my furnace. Now, the furnace on the S8X1 has always had a Y1 and a Y2 landing. So this doesn't change to our new furnace, right? The furnace is exactly the same as it's been for a handful of years. So our furnace board has already had a Y1 and Y2 connection on it. So my Y1 from my thermostat connects to my Y1 of my indoor unit and then continues out to my condenser. The Y2 comes in at that point, connects to the Y2 of the furnace, but I'm not using that wire outside because I've only got a single stage unit outside. Now, this is kind of a layout of the board. So on the board itself, if you look at the terminal strip on the bottom side of it, we've got a Y connection on that terminal board, and we've got a Y2 connection on that terminal board. Now, one of the important things you want to make sure that you do on that control board is set up the two-stage capability of it. If you leave it how it comes out of the box, it'll only perform with one speed fan. So we need to go into the control by using the menu and option button to set up a two-stage compressor. Now, we don't have one, but this is how the indoor unit's going to know to change with the two different fan speeds. So if you go into the control board, hit the menu button and go down to ODU, first thing you're going to see is that it's set to 1-1 by hitting the option button. If you hit the option button again, you will change it to a 2-1. That means two-stage compressor, single compressor, 2-1, two-stage compressor, single compressor. Now again, right, our outdoor unit doesn't have that, but we want our furnace to think that it does. So by activating it here at the 2-1, what it's going to do then is go down to COP and actually tell it, that's our compressor operation fan speed. That's going to tell it to look and activate two different fan speeds depending on your Y1 and Y2 call. If we go into it and hit the option button, we're going to see that cooling stage 1, that's the C1, cooling stage 1, is already preset to tap 3. And if we go to C2, cooling speed 2, right, that would be our Y2 call. We're on speed tap 7. And if you need a video to help you through that, there's a great video on fieldtechhelp.com. It's called S8X Furnace Configuration. It'll actually show you and walk you through that process to do it. There is installation, this is in the installation guide of the unit describing it as well. But, I'm a visual learner. So for me, it was easier to go to the fieldtechhelp.com video and it'll walk me through that. And again, we need to set up airflow for that. So on the furnace, I'm seeing that in this example, I've got it set up with a 3-ton unit. High speed, we want 1200 CFM, and on low speed, I want 840 CFM. Again, the math, 1200 times 0.7 for my low speed operation. So in my 0.7 static column, I can see that I have the availability of 1216 CFM. And for that, I'll need my speed tap 7. Now, again, I'm going to reduce that static pressure when I reduce that airflow. So now I only need 840 CFM. My closest is my 893, and that is my speed tap 3. So again, you want to be able to set up your airflow. Now, in the case of this specific furnace, if you looked at the screen prior, that's actually how this furnace is already preset from the factory, but you're definitely going to want to confirm it. That's what I got. That's the reason for it. I'm going to stay on for a couple minutes for questions and answers, but that's the purpose and the reason why that we are using a 2-stage thermostat with our 15 Seer unit. Davis has a question. I thought that reducing airflow would be less efficient. I always heard 400 CFM for efficiency, 350 is for comfort. Is this not right? To get maximum capacity of the system, yes, you're going to need to get to 400 CFM. But by reducing the wattage on the unit, AHRI is allowing them to reduce that airflow to change the wattage on that blower. So yes, your thinking is correct, but we're reducing the wattage on that motor by reducing that fan speed. I don't see any other questions coming in, so thank you for your time this morning and have a great day.